Mr. H back again, finishing off part 2 of our 7.5 solving logarithmic equations. So as we seem to do on a regular basis in here, we did in the first part, we worked on our exponential equations. We used logarithms, okay? They're opposites, they're inverses to do some algebra work. Now we are going to undo the logarithms. And again, the inverse will be to create an exponential function. This is called exponentiation, which means, think about it, base word, exponent. What we're basically going to do is we're going to turn both sides of the equation into exponents. Now that seems complicated, but it's not really. So here's all we're going to do. Reminder from our last lesson and what we've said a lot around here recently. Okay, a log and its base are inverses. Okay, we've said that a lot in this section. And that's going to be true here as well. So I look here and I see both of these sides, you can only have one log on a side. So if you ever have two on a side, you got to move one of them. So make sure the logs are isolated before you exponentiate. So what we're going to do is we're going to take that 7 and we're literally turning both sides of this equation into exponents, but not for long, because that 7 being the inverse of log base 7 is going to cancel that out. And just like it did in the last section where the exponents just were there all of a sudden and we solved, same thing here once the logs are gone. Now, all I have left is 4x minus 1 equals 2x plus 5, and I'm solving it. So we're back to Algebra 1 stuff, just by doing that one step. And now we just are careful that we don't do anything silly. And nope, nothing silly here. Get my answer, and we're good to go. You're like, Hardy, they won't all be that easy. Well, of course not. But we got to start easy. We got to start getting a little confidence rolling here. So before on this next one, we exponentiate, okay? Make sure the log is isolated first. So we're going to subtract that 2 out of there. Now here's our first big question of the day. If you don't see a baby base, if you don't see a number down here in your log, what number is it? Not 1, 10. Okay, so reminder, this is a log 10. So when I go to exponentiate, you're going to use 10. And you're like, there's not a log over here, though. Doesn't matter. I still got to do it. This is algebra. Whatever we do to one side, we got to do to both. So here, 10 and log base 10 are opposites. They go bye-bye. Be careful here. 10 to the third power is not 30. 10 to the third power is 10 times 10, which is 100, times 10, which is 1,000. You can get crazy numbers with these. And then add your 9 over. You're like, seriously, dude? 1,009? Yeah, they can be kind of big. And get my answer, okay? And then, oh, we got one more reminder over here. Well, we'll talk about that in a sec. Okay. Isolate the log, or natural log, in this case, before you exponentiate. This time I got 2 things I got to get rid of. I got to get rid of that minus 2. If you ever have to choose, you're like, well, here, how do I know whether I get rid of this first or I get rid of this first? Okay, here's my answer every time. If there's add or subtract to do, do that first. Multiply and divide always goes second, okay? It will make life easier. Still got to get the 7 out of there before we do this. Okay, so I've gotten that out of there. Now I got to remember something else. I'm like, oh, I remember that. I think I remember that from last section. You do. E and natural log are inverses. So now we've got the natural log we want to get rid of, and E naturally makes an exponent out of the other side. And then E, if it's been a while, or maybe it's the first time for some of you, I know how some of you work. Okay, to get E, you're going to do second and natural log, which makes sense. Okay, second ln, there's the E, which makes sense because they're inverses. And notice it already puts it into an exponent, so if I want that third, I just put the 3 in. So 20.09. And that works. Now, of course, you're like, oh, seriously, Hardy. Why is every single problem you have, you keep having one more little twist? That's why we put this many examples on here. Sometimes you create extra solutions in your math that don't actually work. Really? Yeah, yeah. These are called extraneous solutions because they're extra. So, all right, Hardy, how's this work? All right, first thing, what number am I going to use to exponentiate since I don't see any log numbers here? Hopefully I've heard about 5 or 6 tens by now. Okay, so 10, 10, whoosh, whoosh, x equals 5x plus 6. Okay. Now, we're just going to solve this. So since this side only has an x, I'm going to bring the 5x over here. U. Negative 1.5. You're like, well, I got an answer. So what do you mean it's extraneous, that it doesn't work? Well, let's try something for a minute, and then I'll give you a quick way to kind of think about this. If I plug in log of negative 1.5, okay, non-real answer. So here's the deal. You cannot take logs of negative numbers. It doesn't matter. Okay, let's quit. So if I do log of negative 11, nope, can't do it. Log of negative 0.01, can't do it. Okay, can I do log of 0? No. Okay, so when you get these answers, you need to watch. Does my answer come out to 0 or negative? If it does, your answer is extraneous. And depending on the program, again, some may call it no solution, some may call it extraneous. You just have to be prepared for it. Some of them might use empty set, okay? There's options here. But any of them, your main thing here is just to remember, if I end up in the negative, okay? Now, be careful. Because like, let's say for instance, okay, that was what you were plugging into. And x comes out negative 1. If you plug negative 1 in there, okay, 5 times negative 1 would be negative 5 plus 6 is 1. I still can take the log of 1. So it doesn't mean, let's do this. When I plug it in, okay, just because you see a negative x value doesn't always mean that's extraneous. You have to see, if I plug it in, will that make my answer, my log that I'm taking, negative? That's the bigger question here. And I want to make sure we're straight on that, so people aren't writing me later going, but I got a negative answer, Hardy, and it says that it's got an answer and you're dumb. Okay, you wouldn't say that. But so I just want to make sure that we're on the same page with that. So I know, shocker of shockers coming here. Okay, now we're going to be solving on this one, okay, page 8, by exponentiating. Again, isolate first if you need to. Hint, hint, number 5 and number 6. Otherwise, just use your exponentiating to both sides and make sure that your value, especially if it's negative, doesn't cause you to try and take a negative log. I appreciate your work with me. We are slowly piling our way through this, and we'll see you next time.